let's do a physics problem using the Casio FX-991 CW class whiz. This is a sponsored video. Casio sent me this calculator. I wanted to show you a couple of the features of the calculator, and then we'll get to the physics. Number one, this calculator has these nice round buttons that are convex so that you can press them very easily. That's always nice when you're typing stuff. The number two thing I want to show you is this math box, which has some apps on the calculator. If I scroll down here to math box and click OK, we have a dice roll and a coin roll. If I click dice roll and then I click the number of dice, let's change that to 2, 5 attempts, and execute, it's going to roll the dice 5 times, 2 dice 5 times, and then we can get a list of the results. So you could use this for some probability experiments. You could use it to simulate radioactive decay, which we do with real dice, but it's on the calculator. Back to the physics. So the problem I want to do is to calculate the gravitational field on the surface of the Earth using the universal gravitational constant. And then I want to find how high, that's a G right there, how high above the surface of the Earth, H, such that the gravitational field is 0.9 at the surface. So the gravitational force between two objects with mass, the magnitude looks like this, where G is the gravitational constant, M is the mass of the Earth, I have that right there, and R is the distance between their centers squared. If you are on the surface of the Earth, the distance between them, R, is equal to R, the radius of the Earth. And you'll notice I said R and R because one's lowercase, one's uppercase, right? Haha. So we want to calculate the gravitational field. If I divide both sides by the mass, I get G equals F over M, which would be G M over R squared. And then G1 is going to be G M over R squared. So we want to calculate that. Now, I'm going to use the radius of the Earth. I'm going to use the mass of the Earth. I'm going to use the gravitational constant in both the problems. So let's go ahead and use the calculator. And I want to enter these as variables so I don't have to type them twice. If I can type them once, that's better than typing them twice, right? So I'm going to go over here to variable, and we have these list of variables that we can use. I'm going to use the radius of the Earth as A. So I'm going to click the value A and go to edit. Now I can type in the value of A. So 6.378 times 10 to the 6, execute. And now it's stored there. If I want to use that number, I just do Shift A right there. Okay. Now let's enter the mass of the Earth as B. So I'm going to choose B right there. Okay. And I want to edit this and enter 5.972 times. I do like the times 10 button instead of EE. So it's the way we write it. It's the way it looks. But 24. I got it. Execute. Okay, so now I have those two. Let's go ahead and calculate the gravitational field right here. But wait, we don't have the universal constant G. We don't need it because it's already here. So I'm going to go to Home, Calculate, and I want the gravitational constant G. So if I click Catalog, I can go down here to Scientific Constants, click OK. And this is the universal gravitational field constant, so it's under universal. And then we have Planck's constant, speed of light, blah, blah, blah. G, that's what I want, G. And I put G right there. So we don't even need to see the number, right? Now I want to multiply that by the mass, which is B. So I'm going to say times, and then Shift B. And it doesn't look right, but it's going to be right. And then divide by the radius squared, which we called A. So divide by Shift A squared. Execute. 9.798. So G1 is 9.798 newtons per kilogram. Now we want to find the value of H. So how do we find the value of H? Okay, so let's write down an expression for the gravitational field. G is G M, and again I said G and G, right? You heard the difference. M over the distance between these squared. Now, I could just call that R, but I'm going to call that R, capital R, plus H, quantity squared. Because I want to find the height above the surface. So R plus H is the distance between these two. Now I just need to solve for h. So I'm going to multiply both sides by this and divide by g. I get r plus h squared is going to be equal to g m over g. And then I can take the square root of both sides and solve for h. So h is going to be the square root of g m over g minus r. So let's put that in our calculator. So remember we already have m and r. Okay. So let's just say, oh, I didn't do 0.9. I'm sorry. So remember we wanted this as 0.9. And this is going to be 0.9 right there. Times 9 G1. That's G1. That's G2. No, G2, I messed up. Okay, it's okay to mess up. Messing up's part of doing physics, right? So G2 is this, and I want that equal to 0.9 times 9.798. That's fine. Okay, so now I want to solve for h. So r plus h squared is going to be g times m over 0.9 times 9.798. 9.798. And then I need to take the square root and solve for h. So I get h equals the square root of g m over 0.9 times 9.798. That's that part. And then after all that, close it, minus r. Now we can do it. Okay. I'm just showing you that people make mistakes too, and that's fine. Making mistakes is part of what we do. Okay, let's just clear that. I'm going to enter this expression right here. Let's just start off with the square root. Boom, right there, square root. Now I need g times m. So g times m, again, we can go to catalog, scientific constants, universal g, and then multiply that by m, which I called b. So it's going to be times b. You'll notice that the square root extends over that. That's what I want. Now I'm going to divide that by, I have two things I'm going to divide by, so I need parentheses. So parentheses, 0.9 times 0.9.798, close parentheses. All of that's still in the square root. I can get out of the square root, because that is not in the square root, by just arrow. Now you see I'm out. Minus r, which is a. So shift a, execute. And I get h is 3.451 times 10 to the 5th meters. So that's how high you have to get above the Earth, the surface of the Earth, so that the gravitational field is just 90%. The end. I'll talk to you later.